It was so bad. We worked in QEMU a lot to get it going, and eventually we got it working, and we got the first 640K of memory without stomping on it, and we were pretty sure that we had this. We threw it away. It was total crap. What Bill wrote in about an hour was so much better that it wasn't even worth looking at assembly ever again. Writing it in C was a much better idea. We were thinking too hard about the problem, and we went in the wrong direction. So that brings us to the actual tool, BIOS memimage, which is a cool package. It's really useful. It is specifically supporting both 32 and 64-bit machines, and it's been tested on both. So you should definitely be able to use this and have no trouble. And it's written in C, and it's very, very small. So the PXE boot dumper is really great. You build the PXE dump utility. One sits on basically on a DHCP server, and it's just a little payload. And you can basically, if you want to, we have our payload down to 3 kilobytes in size. And that's total. So you boot the machine, and once you've booted the machine, it gets a DHCP lease, it loads this program into memory, and it's 3 kilobytes. So you don't stomp on a lot of bits. And depending on the operating system that you're specifically analyzing while doing your research, you will see that you are nowhere near the bits that are important in that operating system. But some people could try to get crafty, maybe put like their secret keys in video, card memory, space, stuff like that. It doesn't matter. This utility would probably find them, except someone that wrote it specifically against this utility. But in a little bit, we'll show you how you can deal with that too. So basically, this is great. It's the best part of the utility suite, I think, because it's the most tested and it's so useful for automation. Being able to shut a machine down and wake it up and send it this payload again is really good for timing measurement stuff. So you could probably make it smaller by simply removing every spurious printf call and all sorts of other things. So it's probably, you could probably hand optimize the assembler. You could get rid of some stuff that isn't necessary that GCC puts into it. Bill wanted also to have a disk boot dumper. We originally wrote one that was a syslinux program, and basically it was a COM32 program. You booted syslinux, and it stomped on a ton of bits, and it did all this stuff that made it possible to program very easily to dump the memory. And it was nice because it meant that all we had to do was turn the machine on with syslinux and run this really small C program, and we were done. Bill was unhappy with this and thought we were being lazy. So Bill, basically, being Bill, he had an iPod, one of the old minis, and that was the only USB disk that he had. So he figured out how to repartition it so that he could simultaneously boot and do memory dumps while also being able to listen to MP3s. Because, like no joke, this wasn't a specific weaponization. This was the only USB disk he had. And he also only had one MP3 player. So what he did was pretty genius. He basically has a small partition for memory dumps and a small partition for MP3s, and the bootloader block isn't important to the iPod, and the firmware is stored somewhere else, so it's pretty simple. The package actually explains exactly how to set up an iPod to do this. So in theory, you could combine this with other iPod-based utilities if you wanted to. But it's great because it was just like, I couldn't bring the USB disk over fast enough, so he wrote this before I got on the bus. It's ridiculous, but it's true. This utility is limited because we didn't feel like putting a lot more time into it. Basically, it captures a single dump to disk. So the first thing we thought about improving was probably to change this memory dump program so that it would dump and it would set an ID and it would have a couple of things from the system collecting some metadata like the clock, things like that if we wanted to. It wasn't really a necessity, so we didn't bother. But if you were going to expand this to do timing on video memory decay in addition, or you wanted to see how it behaved, you could do that if you wanted to with this tool. It's pretty simple. And of course, you could do that with the PXE payload too. So Bill also, just ridiculously so, wrote this in, he ported the BSD TCP/IP stack to EFI. Also in like short amounts of time. It's crazy. This is only 32-bit because Apple has a lot of really undocumented interfaces. And basically, even though they use EFI, it's like Apple's special EFI. So this works on Mac Minis that are 32 bits, and it also works on PowerBooks that are, or I guess PowerBooks that are 32 bits as well. It sort of had some problems. We tried it on a 64-bit machine. We weren't sure that it was a 64-bit machine, and it like kind of went crazy and crashed, and the person whose machine we were owning was very unhappy with that. But we eventually fixed their machine and figured out that they had the firmware password enabled, and then it was a little bit difficult to get around that with the technique we had tried just for rebooting. But eventually we were able to get some 64-bit code bootstrapped, and it did work, but we didn't put any time into it. So the only thing that's actually working is the 32-bit stuff. And I think some of the beginnings of the 64-bit stuff are also in here. So it wouldn't be too much time, but it's probably not worth anyone's time to do this. Although combined with the fact that Apple sort of refuses to fix that bug in any reasonable amount of time, 5 years, it might be worth making it 64-bit to measure decay of all the different Macs and to present that table to Apple and say, hey, this decay is a real problem. You know, it doesn't work well for me and my particular security culture of whatever company or whatever you're affiliated with. Although I don't think anything will change their mind with how that works, so it's probably not worth improving on it. Also, the tool chain, getting the tool chain set up for building the EFI stuff it's interesting and not in a fun way. So the 3 tools that are useful, and I have a good anecdote about one of them, which I'll tell you in a second. One is the AES fix, which is something that Nadia finished writing like a couple of days ago and then improved it like 100% in speed improvements or something like that. Or Alex improved it 100% in a couple of hours before getting on the train to come over here from Princeton. It's basically an implementation of the error correcting code that we talked about in our paper. It's a very simple unidirectional bit correction. So it can unidirectionally correct up to 15% of errors. And to give you an idea about the kind of errors that we saw when doing these analyses, was basically 0.1% error. And if we cooled it, it was pretty much 0. So after an hour in liquid nitrogen, it's not even necessary. But if you had decay, this tool would be very useful when you combine it with the AES key finder. Basically, it finds 128-bit and 256-bit keys, and the keys that it spits out are, you know, tells you the offset, everything that you need, nice little progress bar, it's great. And it finds the keys in memory and it reconstructs them. If it is necessary, you can use the AES fix with it. And the RSA key finder is, again, it's limited in how it has been tested. Tested with Apache on Linux, basically, and it successfully finds RSA keys. So that might be of use. I'm not sure for what, but if you want to download all this, this is the URL. It's blue on blue for a reason. And that reason is that I was having a little bit of trouble with my PowerPoint. All right, it's a crappy knockoff of PowerPoint, but it's basically the same URL as the PDF we have. It's citp.princeton.edu/memory/code. So if you just Google for the cold boot attacks, the first hit in Google, and then /code, you'll be able to find it. And the PGP signatures are actually not up right now, so you might want to wait if you're using this network. So one of the tools that was sort of instrumental in attacking FileVault was VileFault, which Ralph Weinman and I wrote, I don't know, some number of years ago in Germany. And basically, it's an open source implementation of FileVault for decrypting. So you can take an image, and if you have the password, you can pass the password into the program, and it'll decrypt it. And at the same time, you can also, if you don't have the password, toss in an FPGA and brute force it at about 2,000 keys a second, or in software about 300 keys a second. And the FPGAs run about $1,000. So from Pico Computing. So kind of useful tool. I was actually contacted by the Department of Homeland Security recently, which is really funny on so many levels. I have no idea why they thought it was a good idea to talk to me. But basically, they were trying to get FileVault to work with VileFault, and they were having a bunch of trouble. Like, they just could not, for the life of themselves, crack this disk image. It was really interesting, too, because in the email, the thing that they told me was that they were trying to break the FileVault image so that they could find some evidence to hold some guy. So I said, well, I'm not really sure that I feel comfortable with, an intern for the Department of Homeland Security contacting me to break into someone's computer when they aren't actually accused of a crime. And they said, well, if you don't believe that we're with the DHS, we're happy to send you a photograph of us in headquarters. And I said, well, only with a shoe on your head. It went back and forth for a little while, and they said, well, if you're not willing to give us the key finder code, we'll have an agent contact you about the key finder code. And I said, yeah, feel free. I don't know if you're actually from the DHS, because they were sending it from their .edu address, and I thought it was just some clever social engineering ruse that was actually not clever at all. And then I got an email from an actual agent at the DHS who actually authorized them. And looking at the mail headers, you could see all the mail systems that they used inside and out of the DHS. And sure enough, he authorized me to give them all of the things that they had asked for, or whatever it was. And I thought that was kind of interesting. So I ignored their email for a while, and they wrote me a couple more times. And they wrote me to tell me that the key finder code, they had re-implemented it from our paper, and that it didn't work. They were trying to attack the sleep image on a particular person's computer, and I thought it was really funny because they didn't ever actually send me any of the data that I'd asked for, and I don't think I would have helped them, but I was just curious if I could contact the defense with all of this evidence that's being mishandled. And unfortunately they didn't, but if you know anyone that works with the Immigration and Customs Enforcement ICE division for the Department of Homeland Security, you might want to tell them that they have some, maybe smart interns working with some maybe smart agents, but that maybe I wouldn't trust them doing law enforcement. It seems kind of crazy to contact someone that you don't know over the internet and offer to send them evidence without using any crypto and beg for 0 day. And it's just, it's unbelievable that they were doing that. And I felt like it was pretty ridiculous. Eventually they did say that they had a warrant to collect the computer. And I was really surprised because I guess that maybe they didn't read any of the cold boot stuff and they'd only seen the Vilefault stuff, but they had re-implemented the key finder. So I guess that they didn't try any of the other 1,000 attacks against Mac OS X to get these passwords. But it's kind of sort of like an interesting tangent about Vilefault. And I'm sure they're watching this video. So hey guys. Anyway, so I didn't really feel like there was anything unethical about any of this code being released, and I thought it was a good idea because I thought that it would definitely push forward this code in a good direction, and I also thought it would push forward countermeasures. I really think it's a good idea to not simply trust software crypto as the perfect solution. I heard someone talking about database security in the other room, and they were saying oh, it's great, we use crypto for this part of it, and it's unbreakable. So, I don't know, it's a process, right? So in our paper, we said that it would be great if someone wrote a BIOS because all of our tools do actually have some amount of destruction involved. And destruction isn't necessarily negative. You need to destroy to create, to paraphrase from a famous anarchist. But it was not what we wanted for anything that was, I guess, pristine copies. So we didn't ever implement any of the BIOS stuff, but we did mention that if someone wanted to implement the BIOS stuff, that it would be, quite useful, and that all you would need is one motherboard per electrical type. And so someone did, and they contacted me 3 or 4 days ago, and they wrote this program. It's called Core Info, and it's a plugin to the Core Boot project. And basically, it's a BSD licensed library, and it's already pre-built. It comes in a QEMU image, so you can just go to coreboot.org/QEMU, and there's a specific lib payload that you can't read, probably. Just add that in, toss in QEMU, start it up, and it will walk you through all of the memory. It can dump NVRAM. It can do all sorts of useful stuff that a BIOS can do. And using this, it would be possible to do analysis on decay where you didn't trample on any of the bits of memory. So you could see if certain parts of bits stayed longer, for example. Things that are constantly overwritten by the BIOS and only contain BIOS information, you might see that even with unidirectional decay, or bidirectional decay or whatever kind of decay that you're